Hello guys, my name is Craig and welcome to Peri Solutions. If you're new to my channel, please make sure you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. In today's video, we're going to talk about how we calculate area using definite integration. And to do that, I've drawn a curve for you here, right? So we just need to study this curve, right? And of course, this shaded region is giving the area A, right? So for this curve, y is equal to f of x, we need to figure out the bounds for this area A. In other words, the bounds for this shaded region. So we're saying that this shaded region or the area A is bounded by, so it is bounded by the curve y is equal to f of x. And it as well, it is bounded by the lines x is equal to a and x is equal to b. So x is equal to a and x is equal to b. Then as well, it is bounded by this, right, which is the x-axis. So it is also bounded by the x-axis. So to find the area of bounded by the curve y is equal to f of x, the lines x is equal to a and x is equal to b, and the x-axis, we say that a, being the area, is equal to the integral of y with respect to x with the limits from a to b. And as well, we know that this is the same as saying the integral from a to b of y being f of x with respect to x, right? Such that now let's attempt the first question, which requires us to find the area of the shaded region. So for number one, we see that this shaded region, it is bounded by the curve y is equal to 3x squared, the lines x is equal to 0 and x is equal to 2, and the x-axis. So we're saying that the shaded region A is given by the integral of y being 3x squared with respect to x, from the lower limit 2 to the upper limit, from the lower limit 0 to the upper limit 2. And then if we integrate this, we're saying 3 times the integral of x squared is x to the power of 3 over 3. Then from 0 to 2, this is just x to the power of 3 from 0 to 2. And you know that the upper limit will be 2 to the power of 3, which is an 8, minus the lower limit, which is just 0. So 8 square units would be the area of this shaded region for number one. Now for number two, we need to calculate the area of the shaded region that is bounded by the curve y is equal to x times 6 minus x, which you can expand to get 6x minus x squared. It is also bounded by the lines x is equal to 0 and x is equal to 6. Then it is bounded by the x-axis. So we're saying that the area of that region is given by the integral of y being 6x minus x squared with respect to x, with the limits from 0 to 6. So now, integrating this, we're saying the integral of 6 times the integral of x, that will be x squared over 2, minus the integral of x squared, that's x to the power of 3 over 3, from 0 to 6. And this simplifies to 3x squared minus x to the power of 3 over 3, from 0 to 6. So we know the upper limit would be 3 times 6 squared, 6 squared being 36. 36 times 3, that would give us 108. Then minus 6 to the power of 3, that's 216, divided by 3, that's 72. So, and then of course, this is for the upper limit. Since the lower limit is 0, its value is to just be 0. And 108 minus 72, we get a 36. So 36 square units would be the area of this shaded region. So now allow me to erase this part. Okay, allow me to erase this part. Yeah. So I shall erase this part. Okay, so now for number 3, we need to calculate this area of the shaded region. But now we can use the same technique, right? If our area is bounded by, now the area will be bounded by the k of x is equal to f of y. The lines y is equal to a and y is equal to b, and then the y-axis. Right? So we can use the same technique here if our area is bounded by these 3 in such a way that the area would be equal to the integral of x with respect to y, right, with the limits from y is equal to a to y is equal to b, which is just the same as saying here x, we know that x will be f of y. So now for number 3, this is what we're going to do. Since we need x to be equal to f of y, in this case we shall make x the subject of the formula, such that we're saying that root x, y is equal to 2, then root x is equal to 2 over y, then x would be squaring both sides, that would be 4 over y squared, which is the same as 4y to the power of minus 2. So x is equal to 4 over y squared, or 4y to the power of minus 2. So now we shall say this area of the shaded region bounded by the k of x is equal to 4 over y squared, the lines y is equal to 2 and y is equal to 8, and the y-axis is given by the integral of x being 4 over y squared with respect to y, with the limits from 2 to 8. This is the same as the integral from 2 to 8 of 4y to the power of minus 2 with respect to y. And now we shall say 4 times the integral of y to the power of minus 2, that will be y times 4 times y to the power of minus 1 over minus 1 from 2 to 8, which you further want to simplify to get minus 4 over y from 2 to 8. Then upper limit, we are saying minus 4 over 8 minus the lower limit, minus 4 over 2, which would be minus half. And then minus 4 over 2, that will give us a minus 2. Minus 2 minus 2, that will give us plus 2. So minus half plus 2, that will give us 3 over 2. So 3 over 2 square units would be the area for this shaded region. Now moving on to number 4. Number 4 is still the same application. Allow me to erase this part. Part A. So now for number 4, right? With number 4 in as well, just allow me to erase this number 2. Okay, so for now for number 4, we need to calculate the area of the shaded region. But this area is bounded by the k of this y is equal to x to the power of 3. The y-axis, the lines y is equal to 0 and y is equal to 1. So we need to change this equation in such a way that it is in the form x is equal to f of y. So in other words, we're simply making x the subject of the formula, and x would be equal to y to the power of 1 over 3. Simply that, such that the area would be given by the integral of x, which is y to the power of 1 over 3, with respect to y, with the limits from 0 to 1. Then we are saying the integral of y to the power of 1 over 3, that's y to the power of 4 over 3 over 4 over 3 from 0 to 1, which is 3 over 4 y to the power of 4 over 3 from 0 to 1. So substituting the limits, we're saying 3 over 4 times 1 to the power of 4 over 3, that will still give us a 1. And this would be the value of the upper limit. Then the value of the lower limit, we're saying minus 3 over 4 times 0 to the power of 4 over 3, that will give us a 0. So the final answer would be 3 over 4 square units for the area That is here the thing. So this was looking at how we would find the area, right, using definite integration. And please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.